Okay, and here we have question number 4. So the diagram shows some reactions of chlorine. So we have chlorine reacting with hot iron wool to make orange solid A. So I think we can probably work out that that's going to be iron chloride. And then chlorine reacts with sodium bromide solution. And similar to question 3, chlorine is more reactive than the bromine, and therefore can displace the bromide to form bromine and sodium chloride. So a solution of B, so B is going to be sodium chloride, and C is going to be bromine, which is a brown colour. Okay, so the first question says, state, giving a reason, the main safety precaution that must be taken out when carrying out these reactions. Now, usually we might settle for things like goggles or possibly gloves or other sort of standard laboratory safety precautions. But in this particular case, because of the nature of the halogens, because they're toxic, we do need to mention the use of a fume cupboard, or there is such a thing as a fume hood, which goes over the top of an experiment. Okay, so a fume cupboard is needed because the halogens are toxic. Okay, so it's a little more serious than wearing a pair of goggles, etc. Okay, they are toxic. Okay, the next question then asks us, state and explain how the observations for the reaction when sodium bromide would be different if the chlorine was replaced with iodine. Okay, so if we refer back to here, so if we replace this with iodine, then iodine is less reactive than bromine, therefore would not displace the bromide from the sodium bromide. So we would see no colour change. There would be no change in colour because there would be no reaction. Okay, so there are 3 marks for this. Okay, so we need to mention that there is no reaction or colour change. Okay, and this is because iodine is less reactive than bromide in the case of the sodium bromide, but it's the reactivity of the halogens themselves. Okay, and it's unable to displace the bromide from sodium bromide. Okay, so the relative reactivity that prevents that reaction from happening. Okay, and then the final part of this question, taken from an earlier part of the syllabus. Okay, so it tells us that chlorine can form a number of compounds by reacting with oxygen gas. One of these is used in water treatment. A sample of this compound contains 0.71 grams of chlorine and 0.64 grams of oxygen. Calculate its simplest formula. Okay, so you might recall that I suggested that we produce a simple table. Okay, so in the first column, we're going to put in the chlorine, second O, and the information we've got on the chlorine is 0.71 grams, and we've got 0.64 grams of oxygen. Okay, so our first operation in this type of question is to divide by the atomic mass taken from the periodic table. So you look at the periodic table and you find that chlorine is 35.5 and oxygen is 16. Okay, so we'll divide by 35.5 and divide by 16, and that would give us the 2 answers of 0.02. Okay, so 7.71 divided by 35.5 is 0.02, and 0.64 divided by 16 is 0.04. Okay, and then the final act to get the ratio is to divide by the smallest. So whichever of these two is the smallest, obviously 0.02 is smaller than 0.04. So 0.02 divided by 0.02 is 1. And 0.04 divided by 0.02 is 2. So that gives us a ratio of 1 chlorine to every to 2 oxygens. Okay, so the formula there is ClO2. Okay, so that goes in there. Very good.